Hi Year 9, welcome to Waves. I'm sorry I can't be with you today, so what I've done is make you an introductory video to describe some of the things you need to learn about today and help you understand the activities that I've set up for you. So today's an introduction to waves. We'll start to apply this to light this week, but it will also be relevant to the transfer of heat energy through radiation, which we talked about last week and the week before. The fundamental learning intention for today is for you to be able to label a wave and the shape of a wave, identify different parts and describe a wave. So you will need for today the PowerPoint that I'm talking you through. You will also need this worksheet, all about waves. Let's fill the gaps. You don't need to go all the way through that. Don't do changing wave direction, which is down, at the bottom, okay? Just 2/3 of that one will be fine, just to consolidate what you've learnt today. Most importantly, I want you to complete this worksheet here called the anatomy of the wave. And this will show me that you can label a wave and describe a wave in the terms that we're going to introduce right now. So, waves and their properties. Light travels in waves. The reason that you can see and your brain builds a picture of the world around you is because light is reflecting from the objects around you, all objects, and your eyes detecting the wavelengths of light and building a picture for you. Okay. To start today, you need to understand that waves travel through space without moving particles or matter or atoms. Okay, as a wave travels from the sun to the earth, or as the light waves travel to your eye, there is no movement in the particles. Okay, it's literally transfer of energy. We tend to talk about it as a disturbance. Okay, so it's not like conduction and convection, which were based on the movement of particles. It is literally the movement of energy in a wave. You can imagine the waves on the ocean. I'm sure you can describe those in everyday language. What we need to do is add some science terminology to those descriptions so that we're all using the same language to describe a wave. So have a look at the image here. We've got a guy in a pink t-shirt and he's attached a rope to a pipe. And if you can imagine, he's giving it a flick. So he's lifting the rope and causing a wave to travel from his hand to the pipe. So the wave moves up and down as it moves towards the pipe in this direction, from the man to the pipe. So the direction of the wave you would label like this. However, if you want to mark this position of the rope would move up and down, not left to right. Okay, and that's the most important thing to notice and be able to describe in terms of transverse waves. I'm going to show you what I mean. So if you were to mark positions along his rope and he was to flick the rope and send a wave from his hand all the way to the pipe, the different markings would actually move in an up and a down direction, in the opposite direction to the direction of the wave. And that's why we call this transverse. The movement is up and down, even though the wave is going in this direction. That's what we're going to focus on today. Now, the top of this wave, we will call the crest. Okay, so the top points here and here, just like if you're surfing the crest of a wave, riding along the top. We call the bottom of the wave the trough. So they're the first two things that I need you to start building into your language. We're not going to talk about longitudinal waves today. That is for next week. What you can do is actually measure the length of the wave. And to do that, you will go from one crest to the second crest, or equally from a trough to a trough. and that can give you the length of a wave. This can be measured in microns or meters or centimeters. Microns, tiny. Okay, when we're talking about the wavelength of light, visible light tends to be 400 to about 700 microns. So the wavelength will depend very much on which waves you're describing. Okay, radio waves tend to have a very long wavelength, light waves much shorter, and X-ray and gamma radiation very, very tiny wavelength. So far we've done the crest being the top of the wave, indicated here, the trough being the bottom, and the wavelength is the distance between two troughs or two crests. There's one more term I'd like you to be able to use, and it's frequency. Closely related to how long the wave is how frequently the wave moves up and down. Okay, you can describe frequency in hertz, but in year 9 we tend to describe it as waves per second or waves per unit of time. It might be longer than a second, but typically we might give you the x-axis with time and ask you to describe the frequency of those waves. So how many waves are there? How many crests per second? Okay. One more term is amplitude. An amplitude describes how large a wave is. So the larger a wave, a giant crashing wave will have a higher amplitude, and small waves will have a low amplitude, literally describing the size of that wave. We measure the amplitude between the midpoint, so if you draw a line between the centre of those waves as seen on the diagram and the crest, that determines the amplitude. That's what we're going to ask you to measure. And it will be equal to the midpoint to the trough. Okay. When we start to talk about sound waves, the larger the amplitude, the louder that sound will be. And the smaller the amplitude, the quieter that sound. Okay. So that's where we're going to talk about amplitude the most. Okay, compressions and rarefactions we can wait until next week. Just flick through here and see we don't need any of those. Okay, so we'll just go back to a picture of a wave so that I can summarise everything and set you off on your activities. Here we have a typical wave. On one of those waves, you need to be able to label the crest, the top, the trough, the bottom, draw the midpoint or the mean position, measure the wavelength, describe the frequency, how many waves per second, and the amplitude, so the size of the waves. Okay, so I think you're ready to move on to your activities. Start with this one by filling the gaps for me, and then move on to the anatomy of the wave. Part 1, very simple labelling activity. Part 2, a bit more challenging, and you'll have some graph paper in the classroom with you. I need you to draw 4 waves neatly and accurately using the sizes that you're given in centimetres to ensure that your work is precise. Okay, I will have a look at your work next lesson. Email me if you have any problems at all, or pop upstairs and see me. Okay, bye 9B.